sẽ là MC cho buổi hội thảo ngày hôm nay. Đầu tiên em xin cảm ơn mọi người đã dành thời gian tham dự buổi hội thảo. Như mọi người đã biết thì đề tài chế tạo tháp gió đang nhận được rất nhiều sự quan tâm, chú ý của các nhà đầu tư, các nhà thầu cả trong và ngoài nước. Nắm được xu thế đó thì Amcotech cùng với tập đoàn ESAB và KHII tổ chức hội thảo online đề tài giải pháp chế tạo tháp gió ngoài khơi tại Việt Nam. Thì hội thảo sẽ đi qua 4 phần. Mở đầu là phần giới thiệu sơ lược về công ty Amcotech. Tiếp theo là lắng nghe chia sẻ từ chuyên gia đến từ tập đoàn ESAB, khách mời Mr. Ben. Ngay sau đó là phần chia sẻ của khách mời Mr. Paulo đến từ tập đoàn KHII. Và cuối cùng sẽ là phần giải đáp các câu hỏi, thắc mắc của mọi người diễn ra trong suốt quá trình hội thảo liên quan đến hai phần trình bày của hai chuyên gia khách mời. Thì đầu tiên em xin đi vào phần giới thiệu sơ lược về Amcotech. Thì Amcotech là một thành viên của tập đoàn Amco-Well, được thành lập đầu tiên tại Singapore vào năm 1995. Và từ đó đến nay đã thành lập thêm 4 công ty con mới tại các nước như Malaysia, Việt Nam, Indonesia và Thái Lan. Về lịch sử hình thành thì như đã đề cập, Amco-Well được thành lập đầu tiên vào năm 1995 tại Singapore và 3 năm sau đó vào năm 1998, đại diện của Amcotech Việt Nam là Mr. Samuel, ông đã đến khám phá thị trường Việt Nam với một văn phòng đại diện, tập trung chủ yếu vào các ngành công nghiệp, dầu khí và nhà máy đóng tàu. Sớm nắm bắt được tiềm năng phát triển mạnh mẽ tại đây, vào năm 2014, công ty trách nhiệm hữu hạn Amcotech Việt Nam được thành lập chính thức với giấy phép kinh doanh đầy đủ. Và gần đây nhất vào năm 2018, Amcotech là đại diện nhãn hàng ESAB và KHII cung ứng chuỗi giải pháp chế tạo tháp gió. Điểm qua một số sản phẩm của Amcotech thì Amcotech chuyên cung cấp các loại máy hàn từ máy hàn que, máy hàn xung, máy hàn cần cột, máy hàn leo và cả robot hàn từ quy mô nhỏ đến quy mô lớn với đa dạng chủng loại xuất xứ từ châu Á đến châu Âu. Về vật liệu hàn có dây hàn, que hàn, thuốc hàn và các thiết bị khí an toàn với đầy đủ chứng chỉ mà khách hàng yêu cầu. Bên cạnh đó cũng có các loại máy gia công như máy ép, máy chấn thủy lực, máy CNC và nổi bật là máy cắt plasma của nhãn hiệu ESAB. Đây là một lựa chọn tiêu biểu cho ngành chế tạo tháp gió tại Việt Nam. Và đến với Amcotech, quý khách hàng có thể hoàn toàn yên tâm về chất lượng sản phẩm bởi chúng tôi luôn chọn ra các nhà cung cấp với thương hiệu và chất lượng đã được khẳng định. Như về thiết bị hàn, có các nhãn hiệu như ESAB, TPI đến từ Đức, Messer, Haberthum. Về máy gia công, có các nhãn hiệu như KHII từ Ý, Chester của Anh Quốc hay Fintech của Đài Loan. Và đến với hội thảo tháp gió ngày hôm nay thì Amcotech đề cử hai thương hiệu, đó chính là ESAB và KHII. Hai thương hiệu này đều là những thương hiệu với chất lượng hàng đầu thế giới, có kinh nghiệm cao, bề dày, chuyên môn trong việc đưa ra các giải pháp cho ngành chế tạo tháp gió. Đầu tiên đến với nhãn hiệu KHII. Đây là một nhãn hiệu đến từ Ý, đã làm nên tên tuổi của mình với các dòng máy lốc tôn với nhiều model khác nhau, phù hợp với từng độ dày, yêu cầu của khách hàng, có bề dày kinh nghiệm để hỗ trợ khách hàng từ sản phẩm cho đến chế tạo. Công nghệ tiên tiến hỗ trợ dữ liệu từ xa, từ tiện ích đám mây và cũng có đội ngũ kỹ thuật tại Việt Nam luôn sẵn sàng để hỗ trợ chế độ hậu mãi. Sau đây xin mời mọi người xem qua một số hình ảnh về sản phẩm của nhãn hiệu này. Có các dòng máy lốc tôn, lốc hình trụ, lốc hình côn, điều khiển CNC hoặc NC. Và đến với nhãn hiệu ESAB, nổi bật với máy cắt CNC được kết nối với nguồn cắt plasma, đảm bảo đưa ra các đường cắt đẹp với độ chính xác cao. Và giải pháp mà ESAB mang đến cho ngành chế tạo tháp gió tại Việt Nam đó chính là giải pháp chế tạo hàng tự động, hàng cần cột và máy hàng hồ quang chìm tandem ice, máy hàng tự động dưới lớp thuốc, ứng dụng rộng rãi trong công nghiệp, sản xuất kết cấu thép, sản xuất bồn bể, hàng phục hồi. Và cũng không thể không kể đến các vật liệu hàng của ESAB với chất lượng bậc nhất như que hàng thuốc bọc, vật liệu hàng mít, mát, thuốc hàng, que thổi than. Và từ những ngày đầu thành lập cho đến nay, Amcotech cũng đã chiếm được không ít lòng tin yêu hợp tác lâu dài của các khách hàng đối tác lớn như nhà máy đóng tàu Vát, Offshore, công ty CHIA, tập đoàn VinFast. Vậy thì các công nghệ cũng như giải pháp mà vừa được đề cập sẽ được ứng dụng chi tiết cụ thể như thế nào trong việc chế tạo tháp gió tại Việt Nam? Thì sau đây chúng ta sẽ cần lắng nghe chi tiết hơn qua phần chia sẻ của khách mời đến từ tập đoàn ESAB, Mr. Ben. Ông hiện là quản lý khu vực và đã gắn bó với ESAB 33 năm, có kinh nghiệm trong việc lựa chọn đưa ra các giải pháp trong các công trình liên quan đến kỹ thuật hóa, tự động hóa ở các nước như là Indonesia, Thái Lan, vân vân. Và trong quá trình lắng nghe, nếu như khách hàng có câu hỏi thắc mắc gì có thể comment vào khung chat ngay bên cạnh. Chúng tôi sẽ giải đáp vào phía cuối chương trình.
Welcome to the seminar today. Today we'll be going through some basics for wind energy, and this is for Vietnam. Please hold your questions to the end, or you can send them through on WhatsApp or to email. ESAB is one of the first companies in the world to achieve external certification, and that's ISO 9001, 14,001 and OSHA 18,001. This certificate is a group certificate for the whole of the world and is renewed every year. The challenges when making wind towers: to achieve the highest quality, to minimise your production costs, meet the delivery schedules and maximise the profit. ESAB have been supplying wind tower welding since the very beginning, so we have a lot of experience in this. Price too high. We hear this a lot from a lot of customers, and we need to embrace the total economy approach. So when you look at the operating costs, personnel costs, administration capacity, correction and reject costs is a big one, maintenance costs, all of these are under the waterline that you don't see from your initial purchase price. So improvements offered by ESAB can often more than compensate a higher price. We offer support to minimise this under the waterline exposure by buying quality equipment. We have extensive know-how and expertise in wind tower industry. Like I said, we've been in this since the very beginning. We can supply our customers with truly profitable investments. When we start the fundamental designs, it's all driven by the geophysical location and turbine details. So this determines what type of wind tower is going to be placed in what location. And these pictures here, we show a monopile and a tripod. We also have jackets and tripoles, all different types of versions for supporting the towers. So when we look at a wind tower, you can see that we have a nacelle sitting on the top. We have the tower piece itself, transition pieces, and you have the bases, and they can be monopile, tripod, tripile, and jackets. So how do we turn a steel plate into a wind tower? Basic weld design and joint design quality requirements. These are the things you have to consider. The welding process selection, welding consumable selection, properties and performance, and very importantly, the third-party approvals that you're going to need for these predominantly offshore towers. Additional processes, root treatments and coatings have to be taken into consideration, and removing those coatings when you're going to weld as well. Productivity calculations, deposition rates, all of these things have to be taken in. Factory design, process flow with adaptation of environmental concerns. So to achieve the best welding results, it's vital that the weld is considered at the design stage. So before you even start, you need to look at what type of welding you're going to be doing. At ESAB, we have extensive experience in welding design, focusing on high productivity solutions. Welding in wind towers is a large part of the production time because the welding process is not so fast and it does take a long time, and it is a minor part of the total cost. So efficient welding processes are needed to increase the productivity. The selection of that supplier and process are critical to achieving the highest efficiency and the maximum productivity. For proper profitable production flow, reliable automation solutions are paramount. So you need to have reliable roller beds and columns and booms and or gantries. So you need to have ones that are not going to break down. ESAB's efficient power sources, handling equipment, it's developed with the customer's total production needs in mind. It's safe and easy to use because it's European and complies with all the international standards. So when we look at this weld joint design, we talked about this a little earlier, it's the first decision you make. The weld volume reduction should be the aim. If you can reduce your weld volume, you're going to increase the speed that you can weld or produce the article. So if you can reduce it, it's always a good thing. Welding duty cycle, efficient use of welding stations. So you need to look at what the arc on time is going to be for each welding station. Welding productivity increased productivity reduces the welding time. Again, it's all about the speed, efficiency at limited additional costs. It can also determine how many welding stations you're going to need. If you're going to use a tandem with ice, for instance, you may need one less column and boom, which can be a capital expenditure. So we look at the basic flows now. So we look at a plate and we have to cut that and you have to edge prep it. So once that's done, then it has to be formed or rolled into a can. From there, you need to tack weld it. Then it does longitudinal seams, both internal and external. Then you put flanges on if you need a flange. So it's normally a flange on one end and then a flange on the other. So it's normally only two, depends on the design. And then you have fit up and growing lines, circumferential seams, which take the most amount of time, door frames, and then blasting and painting if required. Some monopiles don't need to be blasted and painted. Cutting systems, this is where we start, because you have to cut and prep the plate. Our modern cutting machines, you can get a perfectly prepared weld preparation, accurate and ready for welding. All that needs to be done is a light clean and then you can start. Milling's also become a common alternative, and this is used for a narrow gap alternative. So semi-narrow gap, not full narrow gap. I have a short video here on the process. So we talked about narrow gap on the previous slide. This is becoming a much more common weld preparation for wind towers if we're looking at very thick materials, and in this case it's 80 millimeters thick. Some of our narrow gap applications we've put in place already have been up to 95 millimeters, and these welding heads can go up to about 120 millimeters. You must use a milling machine for these, so it's not an oxy-fuel application. To use these, we have specialised welding torches, and they are tapered at the correct angle, and they're insulated. And this is what you'd have to use for these very narrow gap applications. After cutting and milling, the plates are rolled into circular shapes and tack welded. Power sources, welding heads, control units, columns and booms, roller beds, flux systems and more all have to be incorporated from this point on for all your welding. To do this, you need to weld the internal long seam on both the outside and the inside, so you need the roller beds as well. Circumferential welding. This requires perfect synchronization between the welding equipment, your column and boom or your gantry, and the roller beds to give you the correct welding speed. So circumferential welding joints take more time compared to longitudinal ones. So you need to have a high productivity weld for the circumferential welds. Fit up beds. A lot of people use fit up beds to do a can-to-can application. This reduces the amount of time on the growing line. So it's up to the customer whether they need to do double canning or whether they want to use straight from can direct to the growing line. So this is just a picture of how these growing lines work. Oh, excuse me a moment, I'll just turn on my pointer. Here you can see that these have hydraulic units on the fit up bed and one drive. So this makes it very easy to align your cans so they can be tack welded, and then the circumferential weld can be carried out. And then we move into the growing line format. And this is what most wind towers are using today. So we start off and we have one can. So this is where we're going to start from the long seam. We have a column and boom. We put the can onto the roller bed, and then we weld the long seam, both external and internal. And then we move by crane from that point to your growing line. And the first can is put onto the power and the idler roll by the crane. Then you get the second can and you put it on the fit up bed. Now both of these fit up beds have hydraulics, so you can align the two cans. So once that's done, you push the two cans together and then you align them. Once aligned, you then tag weld or tack weld, depending on what you prefer to hear. Once they're tacked in place, then the internal welding can be done from the external and the internal using a column and boom. Once they've been welded, then you move with the drive roller, power roller and the idler roller, which are on bogies, driven bogies. You move them off the fit up beds. Then you add another can onto your fit up bed. Join those two together or drive them back together. Tack weld. Then you're going to weld the internal and external welding. So then you have three cans joined together. Once those three cans are joined together, you then use the hydraulics on your fit up bed and drop the rollers. So the whole can is then supported on the power and the idler. Then you drive the power and the idler down your growing line. Lift up the fit up bed so you can release the pressure onto the main drive roller. Move the drive roller back into position. Drop that back down. Then you can add can number 4. So once you've added can number 4, you're going to repeat the process, and then you will just drive these together, tack weld, do the internal circ weld, do the external circ weld, and then do the same process over and over again to grow your cans into a tower. and 30 to 35 metres is pretty average for one of these systems. To do all the tack welding, we do recommend that you have a good quality MIG plant. In this case, we prefer to use a Warrior. It's a multi-process MIG plant, which can do stick welding, MIG welding, and you can also gouge with this if you need to. It has very bright displays. It's easy to find the right process for optimizing your settings. It has a remote control, two-stroke, four-stroke, quick connections. There's no tools needed when fitting cables and hoses, so this saves a lot of time. Door frames. The tower doors require special attention, and there is very high pressures applied to door frames, particularly when they're offshore. They can be hit by very large waves, so they have to withstand a lot of pressure. So we have CNC controlled cutting and welding equipment to fulfill this task. Once this is done, blasting and painting is necessary. For onshore towers, of course, they're all painted. Some monopiles are left raw and not painted, so it depends on the design, on who the supplier is. And painting systems, all the blasting and painting systems use explosion-proof motors and electrical cabinets, because we don't want to have any fires or explosions with all the paint particles flying around. Then we go on to welding. The choice of welding affects the deposition rates and the required travel speeds. You can start off with looking at a single wire system, which a lot of people used to use. Twin wire has a great fill process, but it doesn't have very much penetration. Then you look at tandem, which is pretty much the standard for most wind tower producers. And tandem ice, which is becoming more prevalent. Places like SIF and Blatt use tandem with ice. And you have multi-wire systems, which are normally DC, AC, AC. All of our systems use our PEK control. It's a very easy system to use. We've had it for quite a few years. It's very powerful. It's CAN bus controlled. You can select the welding processes direct from the screen, presetting of all welding parameters before you strike an arc. And that also means that you can check your heat input before you actually strike the arc. And it has 255 parameter sets, so you can store in 255 programs for welding, and you can transfer those from PEK to PEK. So if you have 9 columns and booms, they can all have identical welding programs. Constant current or constant wire feed, adjustable dynamic arc control. It's something that a lot of other people don't have, and it stabilizes the arc, particularly when you've got longer cables. USB slot for data backup and transfer. Heat input visible on the display while you are welding in actual real time, or you can have it in presetting mode to calculate before you even start the weld. Power sources, we have conventional DC and AC power sources. They're amongst the most popular in the industry, offering an excellent welding characteristic and a very long lifetime. We also have our Aristo AC/DC power source, which provides additional productivity with some offset and balance configurations. Welding heads. Generally, wind towers are welded using the tandem process, which I discussed before. Tandem ice is an ESAB patented process, and this gives basically the highest deposition rate for a tandem process in the market today. Internal welding on the wharf. We've seen this many times. Long wind towers, monopiles, they can be up to 70, 80, 90 metres in length, and generally have to have the final assembly done at the wharf. So you'll need to look at either having a gantry on the wharf, which also has overhead protection from the weather, because you can't have the equipment being rained on. And internally, they weld using normally a tandem tractor. So that weld prep is a different weld prep to the rest of the weld preps. WPS, for wind tower production, it can be a time-consuming task. You've got joint preparation, currents, voltages, stick-outs, electrodes, welding speeds, offsets, all these things that you have to make sure that you've got the right parameters to give you the maximum productivity. With ESAB, we have a lot of experience with welding wind towers, so we can actually help you out and reduce that amount of time spent getting your WPS in place. Handling equipment. We have handling equipment all the way up to 1,000 tonne. So we can do very small ones down to 5 tonne and all the way up to 1,000 tonne. So you need these welding rotators to support the cans or support the towers and to roll them at a constant speed, and in a lot of cases at a very high speed, so they need to be quite robust. So we have fit-up units, we have self-aligning units, we have conventional units as well, we have hydraulic-driven units. We also use polyurethane rollers for high wear resistance on a lot of the larger diameter monopiles, for instance. You don't want to be going over the long seams with a steel roller because it will then snag and slip. So you really do need to use polyurethane rollers. Built to withstand harsh and rugged industrial environments, these can be built for outside use, and they just need to have a different IP rating, so they're built differently. They are fully integrated to our column and boom for rolling speed via the PEK controller. So when you dial up your speed on your controller, then these roller beds will give you an accurate welding speed. Good handling equipment and good welding equipment, it's only one part. You need to also look at the flow through your workshop. And here we have an example of a layout. We've got a few examples here. And here you've got a cutting machine area, and then we have a forming to make your cans. Then we go to long seams, and in this case there's 2 columns and booms and 4 roller bed sets. And here we've got can to can with 2 more columns and booms. Then those 2 can to cans come over to here, and then they're going onto the growing line. So they put 2 cans at a time instead of 1, which reduces the time on the growing lines. Here's another example. It's a different type of layout here, where we're using a gantry with columns and booms behind, and here are the long seams and the can to cans sitting separately in a different location. Another example, this is the same example. If you're wondering about the column and boom on the end, this one is actually used for putting the flanges on, and these columns and booms here are quite long ones to weld 3 cans at a time. So the externals are welded on the gantry, the internals are welded with a column and boom. Another example, this is a compressed version for a smaller layout, but again, you still have a cutting machine, you still have forming, you still have long seam, can to can, and then the growing line. When we talked about columns and booms, you need to have good quality columns and booms, and you need to have ones which are very safe, because a lot of these diameters of the wind towers now are getting quite large, 8-9 metres in diameter. And when you put those onto a roller bed, they can be 10 metres tall. So you need to have a column and boom which is going to be 12 metres or 11 metres high. So you need to have something which is very safe for an operator to sit on when he's sitting 8 metres in the air and 6 metres out over the top of the weld point. All these columns and booms come with an 8 times safety factor. So we've taken that into consideration and made a very safe column and boom to use. It has full integration. So like I said before, our PEK has full integration into the roller bed systems, and it comes through with one pendant. When we're looking here, this one here is a 9x5 column and boom. This one's in Thailand, but we have here an RCC1, and our operator pendants control everything. So rotation, lifting of the boom, rotation of the boom, starting and stopping of power sources, flux on off, flux pickup on and off. All of those things are all controlled from one pendant here. And it makes it very easy for the operator. Even feeding wire with these switches here for electrodes. He can feed his wires here. It also has automatic joint tracking, which he can control. Flux on. It also has flux empty light. So if you do run out of flux, he knows. Consumables. If you want to make top quality wind towers, you need to have the right consumable. It's pretty essential that you have the right consumable. We offer a full range of wires and flux with proven wind tower productions in mind. 1062, 1071, agglomerated flux for submerged arc welding, used for high demands, low temperature toughness. All of these things, if you've used ESAB wires and fluxes before, you'll probably already know these. Used in offshore construction, wind tower, monopiles, drilling rigs. You can get it in 30, 100, 600 kilos and 1,000 kilo payoff packs. So the wires are available in all those sizes. For fluxes, you can actually get flux tanks in 75 kilo. You can get them in 250 kilogram, 500 kilogram and 1 ton flux delivery systems. One of the things we can offer is our adaptive welding gantries. These actually take all the work away from an operator. They are an option, of course, but the operator only adjusts the maximum minimum parameters. This is going to give you a heat input, of course. The system will automatically adjust the rest: layer, thickness, width, height, voltage, current, travel speed. All of those things are taken care of automatically by the system. So the operator is really only there to make sure it's still operating within its parameter. We talked about ice previously, and I just want to touch a little bit on our ice system because of its high deposition rate. So if we look at a single 4mm wire welding conventional, you're going to get roughly around 7 to 8 kilograms an hour. Sometimes it's less. Some people say they get a little bit more, but average is about 8. If you look at our ice system as a single torch, only running at 70%, we can get up to 22 kilograms an hour. So there's a marked difference in the deposition rate from a single power source for a 4mm wire to an ice system. But the one to really compare is the tandem. If we take a 4mm single wire DC and a 4mm single wire AC, you're going to get between 18 and 19 kilograms of weld metal per hour. If you look at our tandem system, a 4mm lead on the DC to give you a penetration, and then we look at the ice trail for our fill, we can get 40 kilograms an hour, and we have many stations in Southeast Asia running 34 to 36 kilograms an hour, and that's the average. So we know this process works extremely well. I have a little simulation which I will run through, and this is comparing that tandem 4mm conventional and still using conventional power sources, but we're going to change the AC fill to our ice process. So it's 4.2 metre diameter. It's a asymmetrical double V, 1/3, 2/3. It's only 40mm thick material, and we need a 3.5 kilojoule heat input. You still need to have mag joining pass all the way around, which is done by hand. So you still need to have your Warrior or your MIG plant there. So when we look here for a standard tandem, we were getting 17 kilograms an hour, but with the ice system, we were getting 33 kilograms an hour. And because we're depositing more material, we're actually using less amount of passes, which means we're going to have a reduction in our flux usage because there's not as many passes. There's no removal of the tack weld because we're using punch-through technology with this process, and we're 60% lower in the welding time. So this is the same process, and showing you a little bit differently what it was doing, what was happening and also what it was qualified to. So here we can see it's 40 millimeters thick, the root face was 5 millimeter and 60-degree included angle, which is pretty standard. You still need the continuous mag, so we talked about that in the last slide. So there's the fill and the punch through. So when we look at this, we can see that our fill runs were 36 kilograms an hour, but we are also traveling at 1 meter a minute. So that means that the roller bed process, or the roller beds, have to be of a quality that they can roll a very heavy, large diameter vessel, because that's what it is, at 1 meter a minute smoothly. PWPS, we can actually help you out with that. We have programs which can actually give us a comparison to what you're planning to weld and what you can weld by using an ICE process. So we can actually do these calculations for you, and then you can do a comparison of how much time you can save. So this one's a double V, 60 degree, 6 millimeter land, 32 mil outside, 18 millimeter inside. You still need the mag seal run on the inside, the same with every join. So when we looked at it, 8 runs, 3 millimeter overlap, welding speed was 850 millimeters in this case, 27 kilograms on the root run as well, with a heat input below 4 kilojoules. So the slag came out very easily. All Windtower processors now, they're looking more and more, or the owners of the Windtower hours are looking for data logging. Our PEK comes with data log already, comes as standard internally, and you can take that file via USB, or you can get that information out of the PEK via WeldCloud. So this is an option if you want to go for this system. So this will log all your information from each welding head and then store it into a system where you can then log on to that with your tablet or your computer anywhere in the world, and you can see what's happening. Is there a breakdown? Are they welding? Are they welding to the right WPS, etc.? So you can check all functions. We also have our Weld QAS, and this is an accurate calculation of weld parameters. And this is a data logging system, which is a very advanced system. We have a number of these systems already installed in Taiwan and in other sites in Asia, and they have been very successful. So they quantify productivity and provide suggestions on improvements. They have a reduction of non-destructive testing because they're actually doing data logging all the way around the weld. So there's less administration costs. Real-time WPS adherence control makes it easy, and a reduction of auditing, so you don't have to do as much. One of the things that people keep forgetting about welding is shear key. Now, shear keys are used on the outside of a monopile and the inside of the transition piece. They're generally welded with a column and boom and used with sub-arc, or they sometimes use the MIG process. And the purpose is to increase the sliding resistance between the grout and the steel to avoid settlement. So it's something that you may have to put into your line somewhere. If you're going to produce wind towers, you may have to have a separate station for shear key. So equipped with a strong team of experienced designers and developers and installation specialists, and the installation specialists are really specialists, and they're the ones that are going to help out the most. We are prepared to face any welding challenge in the wind tower production arena. Some of our success cases, okay, some of these are a little older now, but they're still in production. So we have Vastus announced construction of the world's, it was then the largest wind tower manufacturing plant in Colorado. ESAB was selected for our ability to design, deliver and service a really large venture like this. Denmark, so this one here was for the largest offshore wind farm, and this was fabricated by Bladt, and we still are supplying equipment to Bladt in Denmark. China, the Tainan Wind Energy, one of the largest scale wind tower manufacturers in China. So we had custom designed automated tandem welding systems for them and 5 single wires systems. So the wire and flux was also supplied by ESAB for their wind tower production. In Thailand, there was construction of 30 transition pieces and they were quite large. We were selected to supply all the welding and consumables for this project for our proven track record. And they used tandem with ice on all their columns and booms and they used also tandem tractors for internal welding. Taiwan, 2019, major upgrade of 7 existing ESAB columns and booms from single wire to tandem, so they could increase their deposition rates from 7.5 to 32 kilograms an hour. Narrow gap tandem mounted to 3 gantries was also supplied. In Australia, but last month we actually won an order to fabricate large bridge pylons, and these are 4 meters in diameter, so it's very similar to a monopile, and the equipment is basically identical. And I just heard today that we have also won another wind tower farm producer in Brazil, and they've placed their order about 2 weeks ago for a number of columns and booms and roller beds from us. Some of our wind tower customers, some of these you'll know, this is just a snapshot. We have probably 5 or 6 pages of them, but some of them are CIF and CUEL, FHI, Blatt Industries, a lot. Vastus, of course, is there. Points to consider. I keep coming back to this about things you need to look at before you start building towers. Also need to look at some of these things because we've found some of our customers do forget these and they can cause some problem in your production rates. So undercover floor space, the available area to actually put your roller beds in for a 30-meter can or tower, which is going to be 5.5 or 6 meters in diameter. So you have 2 lines, you've taken up a complete hall. The weight loading per square meter on the concrete floor. This is so important when you're looking at putting a couple of 100 tons on a set of roller beds. If the floor cracks or moves, then your alignment's out. Power requirements to look after to drive the power sources, because there'll be multiple power sources there for welding. The number of cranes and their capacity. Do they have the capacity to lift what you're going to be moving? Underhook height, like I said very early on in the presentation, that you can have a very large column and boom and the hook from the crane still has to clear that at its maximum. Cutting machines or milling or a combination of both, including plate buffering and storage. Plate splicing. A lot of plates need to be joined because you can only get them in, some places can only get them in 9-meter lengths, some can get them in 12, some can get them in 14. Whichever way, somewhere along the line, you will probably have to splice plates together to get the right forming length to make a can. Forming machine capacity and the buffer storage space. Roller bed selections for each application for long seam, can to can, for your growing line, whatever it's going to be. Always over specify the load handling. Don't go to the minimum. It's not a wise idea. Cab selection for each application. Note the underhook height. So the selection of the cab, they can be different size columns and booms with different application heads. Weld head specification for each, whether it's going to be a single, tandem with ice, whatever it's going to be, you need to select all of those. Consumable selection, wire and flux, including the lead time to get the wire and flux so you can be on time. Factory flow layout, transport of cans and sections inside and also to the wharf for final fit up. We do have a lot of information available on the web, and there are brochures for submerged arc and for wind tower productions and for our columns and booms, our weld heads. Everything is available on our web pages. So there are also videos available and you can get fact sheets. Anything you need is available from our website, or you can ask directly to us.
Every day, people all around the world work with our products. We help our customers to succeed, be it within the power, shipping, transport or process industry. Over the last 100 years, we have been on a fantastic journey and are now heading into the future with an impressive arsenal of technical solutions. Our customers must feel sure that they will always get the right equipment and the best service, and be confident that we will keep our word. It's a question of trust. Over the course of 100 years, ESAB has established a vast amount of trust based on our expertise, our innovative products, and our long tradition of dialogue and collaboration with our customers. Integrity means that we care. We care about our customers and we care about our products. This means that we are always working to find new ways to improve the functionality and quality of our products, but also new ways of looking after our customers. This results in world-class products, support and service. We care about our employees and we care about the environment. In real terms, this means that we try to conserve energy and natural resources, prevent pollution, provide safe workplaces, and supply safe products. For ESAB, the story began in 1904, when the engineer Oskar Kjellberg invented the coated electrode, which he then patented a couple of years later before founding Elektriska Svetsningsaktiebolaget ESAB in Gothenburg on the west coast of Sweden. It was research and development that led to ESAB's first patent, and it is through research and development that we can continue to offer specially adapted solutions that make any job faster, safer, and more cost-effective. An example of our expertise is our beam welding machines. Beams of the highest quality are a requirement for large modern steel constructions such as bridges, skyscrapers, industrial buildings and arenas. Another example of ESAB engineering's continuous development is Telbo, a telescopic boom with several unique features. The most obvious is how compact it is. Where a conventional boom requires as much space behind as in front, a Telbo only takes up a fraction of the space. Telbo is used, for example, in the manufacture of wind turbine towers and platform pillars for offshore oil rigs. Innovation, the capacity for new thinking and to quickly create fresh solutions, is fundamental for our success. We live to develop new products that can help our customers to increase quality while saving time and money. It isn't technology just for the sake of it. We are innovative and groundbreaking in order to be able to renew and improve our customers' operations. We are passionate about delivering results. Innovation doesn't just require new thinking and imagination. Innovation also needs broad and deep knowledge of welding automation and the differing needs of our customers. Friction stir welding is one of the techniques in which we are world leaders. Through friction and high pressure, the metal in two separate pieces flows together without melting. The weld joint consists of the original metal, and no impurities are created. The result is as strong as the original metal and requires minimal post-treatment. The technique is used in very demanding situations, such as in passenger ferries, trucks, and rocket fuel tanks. Our world-leading narrow gap technology is a process for submerged arc welding of narrow joints in thick materials of both large and small diameters. Compared to conventional techniques, narrow gap can significantly reduce welding time and at the same time reduce the consumption of filler material. The technique is used for welding turbine shafts for the power industry and large reactor vessels for the nuclear industry. Hybrid laser technology combines the best of both worlds. The deep weld penetration and low heat transfer of laser welding combined with the excellent welding characteristics of MIG or MAG technology. Weight-optimized ship sections, steel bridge constructions and excavator arms are just some examples of the technology's areas of use. Another example of our efforts to satisfy our customers' requirements for quality, price and delivery reliability is that we manufacture the bulk of our products ourselves and apply the lean production philosophy. This means that we use standards and clear structure to eliminate waste in all aspects of production. The heart of manufacturing is in Laxor. This is where we manufacture not only welding machines, column and boom, but also circuit boards, power sources and lots more besides. Our turnkey solutions are complete installations that, in addition to welding equipment, also contain, for example, portals, column and boom, or our advanced roller beds, which are a requirement for handling and welding large cylinder-shaped objects. Machines for manufacturing chains of all lengths and sizes are another example of products with a high level of automation developed in Laxor. When you choose to work with us, you don't just get a supplier. You gain a long-term partner that is never more than a phone call away. Regardless of whether we help you over the telephone or if you receive a visit from one of our talented local technicians, you can be sure that we are always there for you and will do our best to keep your production running without exception. We can also tailor training for your specific needs, for example, process training or training in filler materials. Led by integrity, experience, innovation and partnership, we continue to develop in order to offer our customers the best products and services on the market. This is how we do business. This is how we look after our customers. This is how we reach our goals.
So, this is a pretty unusual wind tower, but if you can dream it, ESAB can weld it. Thank you very much for listening.
Thank you so much, Mr. Ben. Rất cảm ơn phần chia sẻ hết sức chi tiết của Mr. Ben. Đến với phần hỏi đáp. Ban tổ chức rất cảm ơn mọi người đã cùng lắng nghe và đặt câu hỏi cho chúng tôi. Và ngay sau đây chúng tôi sẽ nhường lại phần giải đáp các câu hỏi cho Mr. Ben và Mr. Powell. Hello, Mr. Ben. We got some questions from the customers and we are waiting for your answers.
Yeah. Sorry, my apologies. Question 1, where is it? Hang on a second, I'm just trying to find question 1.
Natalie, why, to make it easier, why don't you repeat the question, each of us, so we can answer better this way? Because I think we are managing different multiple screens. We are a bit troubled to get the question.
Well, I've got one here. It says, what's the standard transition time from long seam welding to circumferential welding? If you've got an ESAB column and boom system, or basically any of them, they should be able to transition from long seam welding to circumferential welding in roughly about 10 to 15 minutes. Most of the systems have a swivel point at the front, but then it's just going to be an alignment of your flux delivery and your flux pickup again for changing from long seam to circumferential. So it doesn't take that long to transition from long seam to circumferential welding. That's pretty average, about 10 minutes, depending on whether, of course, what the equipment they have on it, but that's pretty close to it. What's the other questions here? It says one here. It says, what's the total duration to produce a monopile? That's a pretty open-ended question because it depends on the length of the monopile. It also depends on what growing line you have, what welding process you're using, what weld preparation you're using, how many joints you're going to have, because some people might want to be rolling 3 meter plate and some people might be rolling 4 meter plates, so there's less welds to do. So it's pretty open-ended. What we need to do there is actually have a look at what you want to do, and we can actually calculate the arc time of how long it takes to weld the whole monopile. And from that, then you can then extrapolate, okay, movement from this point to this point is that time, and you'll have to build up your own cycle times. But we can help you do that, but we'll need some details on what monopile you're going to weld to start with. What other, is there any other questions there for me? What's the main setback during Windtower monopile fabrication? I can tell you that mostly the biggest time consumer, other than welding, is really the transport of components. When you look at internal transport from getting the plates and then transporting them to the cutting machine, taking those plates off, transporting them to a splicing machine, taking them from the splicing machine to the forming machine, taking them from there onto a long seam station, taking them from there to the next station, which might be can to can, and then taking them again onto a growing line. And then when the growing line's finished, then and you've got your monopile, then you're going to have to transport that to the wharf somewhere. So when you think about it, it's a lot of transport involved in doing any sort of wind tower production. And that's why we did spend a little time there in the presentation going through layouts, because the layout of your factory is so critical to reducing the amount of transport time. Because if you haven't got 10, 15, 20 cranes available, then a lot of times you'll have to wait for a crane. So that then becomes a bottleneck in the flow of producing. So I would say transport is probably the biggest thing that you need to consider in that point. Are there any more questions? Are there any more questions for me?
Hello, Mr. Ben. There is another question from the chat room. Please see.
Yeah, what is that?
Show more detail of arc welding technology.
One more time. What was that?
Yeah, hi, Ben. I think we are running over time now.
Oh, okay.
So, yeah, so this ice welding from this question of Mr. KINH, Thank you for your question, and I think we will do a separate discussion about this, so that we can skip to the next question from for Fasin, because there's another 3 or 4 questions.
Rất cảm ơn phần giải đáp của Mr. Ben và Mr. Paulo, và còn rất nhiều câu hỏi nữa, nhưng vì thời gian hội thảo có hạn cho nên là chúng tôi sẽ vẫn tiếp tục trả lời giải đáp của những thắc mắc của mọi người qua mail cá nhân. Và mọi ý kiến đóng góp cũng như là phản hồi hay hỗ trợ về kỹ thuật, mọi người có thể liên hệ với Amcotech thông qua thông tin như trên màn hình. Và cũng đừng quên tham dự hội thảo online sắp đến của NGHIệp Fasin để được lắng nghe chi tiết hơn về các giải pháp cho máy lọc tôn ứng dụng vào công nghệ chế tạo tháp gió ngoài khơi vào ngày 9 tháng 9, cũng vào lúc 2 giờ. Và đến đây thì thời lượng hội thảo cũng đã kết thúc. Một lần nữa xin trân trọng cảm ơn mọi người đã dành thời gian lắng nghe và cũng như là đặt câu hỏi phản hồi cho phía ban tổ chức. Nhưng hội thảo sẽ vẫn mở trong khoảng 15 phút tiếp theo. Mọi người có bất kỳ câu hỏi hay ý kiến gì có thể comment vào khung chat. Chúng tôi sẽ vẫn tiếp tục nhận và phản hồi cho mọi người thông qua mail cá nhân. Xin trân trọng cảm ơn.